right, so every 26 seconds in the United States, there is a victim of violence. So as long as it took me to say that sentence, we just now had 2 more victims of violence. Now let's imagine that this next image is one of those victims. It's a woman who has come in for a medical forensic exam after experiencing violence. And she tells me her story. She tells me what has happened, that she's been hurt. And I go to examine her arm, and this is what I see. Do you see anything? And this happens across the United States all the time. Every day, we're faced with situations where we have to assess for injury, and we're faced with a situation where we don't see anything. But is it that nothing happened to this victim, or is it that we just can't see what's there? So this same victim, I used a technology called alternate light source, ALS, and this is what I see. You can actually see the injury that wasn't there before. It makes it more visible. We have something to document. Because bruises are not just bruises when it comes to a medical forensic exam. I'm a forensic nurse. And when I see a patient, I document what I see. And that documentation shapes the care that they receive, whether or not they actually get the right kind of care, whether or not they actually get a case that goes to court, and whether or not they actually feel believed. If I don't see an injury, I am forced to actually say, no injury observed, normal exam, nothing there. I mean, I have to document something. But the problem is, in this particular case, that the absence of evidence, unfortunately, as you guys have probably heard this saying before, is evidence of absence. What I document will be seen by the prosecutor, will be seen by the jury, and that's what they see. And it's made even harder by the fact that bruises look so different on different types of people, in different situations, in different conditions, in different contexts. For somebody who has a lighter skin tone, you often see more colorful bruises, bruises that are easier to see. But if you take that exact same bruise situation, the same mechanism, put it on somebody who has darker skin tone, then that bruise is harder to see often. Looks, and I'm putting my fingers in quotes here, less severe, less painful, less violent, especially when you use standard cameras and white light. So when it comes to this problem, a perfect solution you guys might be jumping up and down about is AI. Let's use AI to solve the problem. Let's get thousands of pictures of images, and let's train in some models, and let's solve the problem, making bruises visible to everybody. There's a problem. There is no data to solve this problem. There are no comprehensive data sets of bruises of diverse skin tones. It doesn't exist. Trust me, we've looked for it. There's lots of data sets on melanoma and all these other kinds of skin conditions. Just seems like nobody really cares about bruises. So we need a comprehensive data set in order to actually train models. So let's say, hypothetically, we went out and grabbed a bunch of images, from clinical sites and that kind of thing, put together, trained some models, but the problem is these images that we've gotten from clinical sites are what you imagine. There are bruises that are really easy to see, probably newer bruises on people with lighter skin tone. And let's say we actually train a model that is 95% accurate. Woohoo! Well, accuracy isn't equity. It doesn't actually solve the problem. So what are we doing about it? So I am a co-director of the Injury Analytics Lab here at George Mason. We've become quite the experts at alternate light source, developing clinical practice guidelines, doing tons of research, and we've discovered that, unfortunately, alternate light source is expensive. And so also requires a lot of training to interpret those weird pictures you guys were just seeing, okay? And unfortunately, a lot of people don't have access to that kind of level of technology, especially caring for victims of violence in areas that really need it. So this is what we've done. We are working on a major project called Equitable and Accessible Software for Injury Detection, or EASID. Catchy name. I know, we're excited about it. So what is it? We're developing an application that combines an alternate light source and AI in something that's more accessible, that's cheaper, and smarter. It has 3 very important components. I'm going to skip past, which is probably the most important thing, which is data, and talk about imaging. So we're taking that expensive, sometimes cumbersome alternate light source technology, paring it down to something more easier to maneuver equipment, add on to a tablet device. And also using deep learning to build models to be able to detect and characterize bruises accurately based on data, which I'll talk about in a second, and be able to guide the clinician to actually do it. So the clinician doesn't even have to have the expertise in alternate light source, forensic documentation. It'll help them with that process. It'll guide them, make them feel more confident. So what does this do? It makes the technology more accessible and put in more people's hands. Think rural communities, third world countries, very exciting. But this cannot happen without the data. As I mentioned, that's the hardest and most important part. And through local and international crowdsourcing partnerships, we're creating the first of its kind national bruise data repository here at George Mason. Secure. I heard the last talking about cybersecurity. That is a huge concern for us because of PHI. So that is critical for us. So this is the biggest part, and we're hoping this is going to be something that's publicly accessible and able to be shared with researchers and clinicians alike. It includes images, multiple images of bruises over time, with structured data, everything you need to build all sorts of AI models and solve important questions. But we're not trying to replace what nurses do. I want to be very clear about that. You'd be surprised. Nurses are very paranoid about this. Is AI trying to replace us? We're trying to augment what they do. Augmented intelligence, not artificial intelligence, is a goal. But we keep asking ourselves very hard questions as we continue to do this work. Who is represented by this data? What are we missing? How do we define what ground truth is if a bruise is hard to see? How do you even know the bruise is there? To be able to teach the computer models where the bruise is. And who is ultimately accountable for when the algorithm goes wrong? In the lab, in the courtroom, seeing is not neutral. It is up to the AI to ultimately make a choice as to what is visible. And ultimately, when it comes to AI, accuracy is not everything. It's who is seen, who is believed, and who is protected. Thank you.